Boys and girls, it's Miss Bassell. We are going to go over your topic 1 and 2 test. I'm going to make this video so that you can fast forward and rewind without having to watch the whole video. That way, if you only missed a few of the test items, you can fast forward and watch that. So you're going to need your math journal with your work in it so that you can look at your work on these 20 math problems as we talk about every day in math, even though worldwide, we've seemed to have gone digital on everything. When we do math, we might be looking at a test on a computer, but we're doing the math still on pencil and paper and then entering our answers. So I'm just going to look at these test items. I've actually already made this video, but I made it without sound. So I am having to remake the video. So the work's already kind of been worked out here. So let's talk about number 1. We want to know which set of place value blocks represents the difference between 3 and 4/10 and 1 and 25 hundredths. So I can't answer that. Can't even pick one until I actually do the subtraction. So what you will notice is in order to subtract 1 and 25 hundredths from 3 and 4/10, I wrote the equivalent decimal 3 and 40 hundredths. You can see my careful work of regrouping. So I'm looking for a set of place value blocks that shows 2 holes shaded and 15 hundredths of another. So if you look, that would be A. 2 holes are shaded, 1 column, which are 10 hundredths, and then another 5 hundredths. So A is the answer. All right, let's look at number 2. Want to know what the sum is of 1 and 17 hundredths and 1 and 86 hundredths. Don't even need the place value blocks for this. I don't know if this test item just has the place value blocks to confuse you, but all we need to do is line up the decimal points, drop it down, carefully add with some regrouping, and we get 3 and 3 hundredths, a pretty straightforward answer. Answer B. All right, number 3. A team of 4 students ran a relay race. Each runner's time for his or her leg of the race is recorded below. What is the total time? That's my key word there, of the team. So we're going to add up the 4 times. Again, we have to carefully line up the decimal points. You will see that for 29 and 6/10, I wrote the equivalent decimal 29 and 60 hundredths. I did the same thing for 27 and 9/10. I wrote its equivalent decimal 27 and 90 hundredths. That way I have 2 place value positions behind the decimal point for all of my add-ins. When I carefully add, and you can see my regrouping at the top, I get 114 and 3/10. Now, where the little problem might have come is that, 30 hundredths, is the only thing in the answer bank is 114 and 3/10. So in addition to seeing that you know how to add decimals, it's also checking that you understand equivalent decimals and that you recognize that B is the correct answer because 114 and 3/10 is equivalent to 114 and 30 hundredths. All right, let's look at number 4. Hannah purchased 11 and 6/100 pounds of apples. 6 and 57 hundredths pounds were Red Delicious apples. The rest were Granny Smith apples. I want to know how many Granny Smith apples. So, we do these with bar diagrams a lot in class. So if the total weight of all the apples is 11 and 6/100 pounds, and I know that 6 and 57 hundredths are those Red Delicious, and I want to know these Granny Smiths, the weight on those, this is a subtraction problem. So this is what was going on in my head. Here is my very careful regrouping when I subtracted, and I get 4 and 49 hundredths. A real quick way to check this problem is to add your 4 and 49 hundredths to 6 and 57 hundredths, and that total should be 11 and 6 hundredths. All right, number 5. Carter purchased 3 items at a concession stand at Friday night's game. One item for $2.25, another item for $4.50. The total cost for the 3 items was $8, and I want to know the cost of the third item. So just like the bar diagram above, here would be our 3 diagrams. We know that everything added together gives us $8. We know that one item is $2.25, another is $4.50. We're looking for that third item. So what I want to do is get a subtotal to find out how much the first 2 items are. And that's why I'm adding them together to get $6.75. Once I know that, I can subtract it from $8 to get that missing part. Now, the problem with this question is they're trying to bait you with a decoy answer, $6.75. If you do not understand that this is a 2-part question that you're problem solving, you notice that step 1, you're adding your 2 items and you get $6.75. If you lose track of what you're doing and get excited because you see that answer in the answer bank, you have just fallen for their trap. And test writers love these little traps. So what we have to stay focused on is, what is $6.75? $6.75 is simply the cost of 2 items. To find that third item, we have to subtract $6.75 from $8. Careful regrouping, and we get $1.25. This one is super easy to check. If you take your 3 items, what do they need to equal? Well, look at your bar diagram. They need to equal $8. So if you carefully add, I get $8 and I know it's correct. Anybody that would have fallen for the decoy of $6.75 would have gotten an answer much more than $8. So you would have known your answer is wrong. So sometimes just taking those 30 seconds to check problems will save you. Number 6, Marcus lost his swimming cap and goggles at his last swim meet. He purchased a new cap and goggles set for $23.19 at the sporting goods store. If he gave the cashier $40, how much change did he get back? So anytime that you are purchasing an item, you subtract your total from the cash you give to the cashier, whether you're at a sporting goods store, a concession stand, the Dollar General, it doesn't matter. You're going to see what your change is. So here's my work where I carefully subtracted. And again, this beauty of this problem is you can take the difference, add it to the subtrahend, and it should equal $40. So you can go out to the side, check by adding the change to the cost of the sporting good item, and it should equal $40. It does, so I'm correct. That change should be $16.81. All right, number 10, we're halfway there. Number 10, Giselle weighed 2 different samples of chemicals in her science class. The first sample weighed 39 500 grams. The second weighed 56 7/10 grams. She then mixed the 2 chemicals together. What was the weight of the combined samples? So guys, when we're combining, we're adding. So the only thing you had to do here was to write the equivalent decimal for 56 7/10 as 56 70/100. Line up your decimals in your add-ins and your sum. Carefully add and regroup, and you get 95 75/100 grams. Number 11, which statement is true about the value of the underlined digit? So underlined, we have a 40. Beside it, we have the 4. And what I know about that is 44 looks like this when we have our place values with our 1s and our 10s. So I know that this 4 is 10 times the value of the 4 in the 1s place. 40 is 10 times the value of 4. All right, so this one is C. And again, we're just making sure that we understand how the place value is set up with powers of 10. As we move left, each identical digit has a value 10 times that of the one to its right. As we move to the right, each of those decreases by 1/10. All right, number 12. In what number does the 6 have a value that is 1/10 the value of the 6 in 34,761? So I noticed that that 6 is in the tens place. So if it's 1/10 the value, then that means we're going to the right, and that means that I would need to have a 6 in the ones place. The only one of these answer choices that has a 6 in the ones place would be 78,426. So we're going to pick D. Okay. Again, this is very much like number 11. We're just making sure that we understand how the place value system is set up. All right, number 13. Which digit is in the hundredths place? So I just made a little note. Here's my whole number. Here's my decimal. So we would have tenths, hundredths, thousandths. You guys studied tenths and hundredths last year. We just added thousandths this year. So if I know where the place values are, I know I'm looking 2 places to the right of the decimal point. So that 9 would be in the hundredths place, 2 places behind the decimal point. All right. I think a lot of people will instinctively rush over and they see hundreds and they're thinking of the whole number, but that is spelled hundreds, right? The THS in tenths, hundredths, and thousandths means we're talking about the decimal and not the whole number 0, okay? All right, let's keep moving. Number 14. Oops, let's see. Wait, whoa, what happened? Did I really get off track? Oh my goodness. Now I'm really going to mess up my video, but I am not going back. So let me just pick up the ones that I missed. All right, sorry about that, guys. Number 7, which value for n would make this statement true? So I'm looking for a number less than 47 and 82 hundredths. I see that every single one of these has the whole number 47. So I'm moving over to the tens place, TENTHS, and I see a 2, a 9, a 9, and an 8. So if it's going to be less than 8, it can't be the 8, the 9, or the 9 in the tens place. It has to be this number right here. Another easy way that I can see this is just by having a good listening ear. And since I know that all these have the whole number 47, I have 82 hundredths. Well, this one is 22 hundredths. 22 is less than 87. This one's 99 hundredths. 99 is greater than 82. This 9/10 I rewrote as the equivalent decimal, and 90 hundredths is also greater than 82 hundredths. And here I took off the 0 and to have an equivalent decimal, and this is equal, 47 and 82 hundredths. So my answer is A. Number 8, the heights of 3 students were measured. Callie, we have her height. Ariel, we have her height. And what we need to start with is this third bullet of information. Savannah is taller than Ariel, but shorter than Callie. So we're going to put these girls in order, tallest to shortest. I started with some blanks, and I know that Savannah, is taller than Ariel. So I put her to the left of Ariel. And then I see that she's shorter than Callie, so that means Savannah is middle in height. Then I put the girls' heights from bullets 1 and 2. And then what I clearly see is Savannah's height has to be less than 61 and 815 thousandths, but it has to be greater than 61 and 37 thousandths. So I'm going to ignore the 61. So I'm looking for something that's less than 815 thousandths, but greater than 37 thousandths. So put a 0 on the first answer choice. These are all 61 inches, so the whole number is not going to help me. 920 is 920 thousandths is equivalent to 92. So right then and there, I know that this one's going to be too large, right? 920 thousandths is going to make her the tallest girl. So that's not true. Savannah's the middle height. The next one, I have 61 and 7 thousandths. So when I look at that one right there, I see very clearly that she would be the shortest if this was her height, and that's not the case. Right here is my answer. Now I'm going to rewrite this as 61 and 250 thousandths because I can clearly see that 250 thousandths is less than 815 thousandths and it's greater than 37 thousandths. And again, 999 thousandths would make her the tallest if that was her height. So I'm finding it in the middle. All right, number 9, Camden and his shirt and tie. He bought these 2 items. Guys, we just added up very carefully. Careful regrouping. We get $53.87. I apologize. I already did 10, 11, 12, and 13. So that means we're looking for, my goodness, 14. The number right here is the same as what word form. So if you can carefully and correctly read numbers, and we have practiced that in class the last few weeks with these new decimal numbers, if you can carefully read it, you can find the word form real quickly. I see I have 1 decimal place, so that means I am in the tenths. We read this 6/10. All right, number 15. I'm looking for the decimal with the greatest value. What I did, I used the strategy in class. I stacked up all 4 of the numbers, and I wrote them out to the thousandths place, since the last 2 numbers go out to the thousandths place. So 200 thousandths is equivalent to 2/10. 270 thousandths is equivalent to 27 hundredths. And then I have these 2 numbers already written out to the thousandths. So I'm looking for the greatest value. Guys, the 0 doesn't help me at all. The 2, it's either going to be, it's not going to be this one. It's either going to be 200 thousandths, 270 thousandths, or 231. So I'm going to go to the hundredths place. And out of those 3, I have a 0, a 7, and a 3. 7 is the greatest. That makes this one the greatest valued number. So going back to the answer bank, this was 27 hundredths. All right, I just have its equivalent decimal here. Number 16, I hope you use the place value blanks, the decimal point, and the strategy I taught in class. So I look over. 6 times 100 means that I'm going to have a 6 in the hundredths place. So these are my ones, these are my tens, these are my hundreds in my whole numbers. So I have a 6 in the hundreds place. Then I look over and I have an 8 in the hundredths place. So I know I'm going to have 2 decimal point or decimal places behind the decimal point. So these are the tenths and these are the hundredths. All right, so I put an 8 in the hundredths. Now I see I have a 4 in the tens place, a 3 in the ones place, and a 5 in the tenths place. Put it all together. This one's pretty simple, 643 and 58 hundredths. Number 17, however, is a little trickier because there are quite a few zeros. And if you tried to do this without that strategy, this one was probably one you're going to miss. So when I look at it, the largest place value is a 5 in the 10 thousandths place. So the first thing I did was put my 5 place value slots for those digits. I know I'm going out to the thousandths place, so I need 3 decimal places behind the decimal point. So a 5 goes in the 10 thousandths and an 8 goes in the thousandths. Now, in this particular problem, I could pick either one. I just chose this one at the top. It's the same. Some have decimals. These have fractions, naming the decimal parts. 3 goes in the hundreds place, a 7 in the ones place, a 4 in the tenths place. So I had 3 zeros that I needed to put into that number. They're not mentioned in the expanded form because they have no value, but I need to know to put them in my number, 50,307 and 408 thousandths. Number 18, I want to know which of these is true. You can kind of see my work where I'm comparing. So I started. I see 304 thousandths is greater than 34 thousandths. So that's not true. 814 thousandths is actually less than 841 thousandths. And I know that from the hundredths place. So that's not true. 131 thousandths is actually greater than 113 thousandths. I see that in the hundredths place. This one better have been true or I would have been in trouble. 1 and 540 thousandths, yes indeed, is greater than 1 and 450 thousandths. And I see that in the tenths place. All right, I'm moving right along. Like I said, Miss Bassell made a video yesterday, and unfortunately, the volume on my computer had kicked off somehow. So I have spent an hour trying to reset those settings, figured it out, and now I'm making your recording with sound. All right, let's look at Owen. He studied the amount of snow that fell for 10 years. The average for 2 months are shown in the table. So we have two decimal numbers here, and we want to know what's true. So this reminds me of what we just did. So guys, 10 and 786 thousandths is not equal to 10 and 739 thousandths. I see that in the hundredths place. B, 10 and 786 thousandths is greater than 10 and 739 thousandths. I see that in the hundredths place, where we have 8 hundredths is greater than 3 hundredths. C is not true. 10 and 786 thousandths is not equal to 10 and 739 thousandths. I see that in the hundredths place. And last but not least, 10 and 786 thousandths is greater than 10 and 739 thousandths. I see that in the hundredths place with the 8 and the 3. So can't be anything but B. And last, made me so sad when I saw people pick answer choice D. And the main reason is this large square has a value of 1. So that means that these 100 little squares have a value of 100, written either as a decimal or a fraction. We could use this as a fraction model or a decimal model. So what I know is I don't have a whole number because this is less than one whole. If the entire thing was shaded, all 100 little squares, I'd have one whole, but I have less than that. I see one column. One column are the tenths, and I see 5 of the little squares coming down the second column, which are my hundredths. If I wanted to count them individually, it's 15 hundredths. All right, answer is B. So this was your test that you took on chapters 1 and 2. So hopefully you're able to look at what kind of mistakes you boys and girls are making. It's important to know the concepts that are in this test because these match the standards that I am required to teach in 5th grade for in the state of North Carolina. I've covered them, but also it's important to be able to answer questions with those concepts in a test format. So hopefully going over the test helped you a little bit with your test taking strategies. Again, you saw that Miss Bissell showed work on just about every one of those 20 problems. So when you opened up your math journal, you boys and girls should have work on just about every single one of those problems that you can look back at. If you don't, then that might be your problem. You might be a multiple guesser when it comes to test. And well, that's not a good strategy. It's not working for you. We want to make sure we're doing the math on paper using the strategies that Miss Bissell teaches in class. All right, there it is.